So good morning students. So in yesterday's class we studied about that hybridization of the different molecules and gave you homework also. That is yes, you have 6 molecules. I'll continue with the same. Okay? That is S has 6 molecules. Okay? So this yes, you have 6 molecules. What is its hybridization here? So sulfur is there. Its atomic number is 16. Configuration is 1s2, 2s2, 2p6, 3s2, 3p4. Okay? Here which one is the valence shell? This is the valence shell. Okay? So now the second step is once we know the hybridization state of this molecule, then the next one is what? Box diagram. That is box diagram for take box diagram in ground state. Okay, so valence shell we are considering means this is 3s option, this is 3p option. Okay, so in the 3s option, of course, 2 electrons are there. In 3p, 1, 2, 3, 4 electrons are there. Now comparison. So here, the number of bonds is equal to how much? 6. But the here of number of unpaired electron is equal to how much? Only 2. So we require extra 4 electrons for bonding. So students, this is K shell, this is L shell, M shell means of course here 3D 0 is also there. Means we need to write D orbital here like 1, 2, 3, 4, 5. That is 3D orbital. Initially at ground state there is no electron in this D orbital. Next second one. Box diagram in first excited state. Now write. So this is 3s orbital. This one is 3p orbital. This one is 3d orbital. Okay, so here if I write the electronic configuration here, same. First excitation means one of the electron of this p orbital is excited to d orbital. Remember, s orbital excited to p orbital if empty orbitals are there. If there is no empty orbital, this directly goes toward d orbital. Are you getting? Means when the electron is excited, they occupy empty orbital. They cannot be paired up with any other. Means, for example, listen. So if s electron is going to excite, means this electron cannot be paired up here and here. It directly shifts here. Means the electrons in the orbital when they get excited occupies empty orbital. They couldn't pair up. Okay, so this is the first electron of p orbital excited to d orbital. Now listen, here 1, 2, 3, 4 unpaired electrons are there. So 4 electrons are ready to bonding. But here the number of electrons required is how much? 6. Then of course we need another excitation. Next. Box diagram in second excited state. Box diagram in second excited state. In this, of course, this is 3s, this is 3p, this one is 3d. This is our present electronic configuration. So students, next in the double excitation what happens? Which one is the paired electron here? This 3s is option. 3 is also half filled, 3d is incompletely filled. So now the electron of this directly jumps to here because as I told you, the electrons when they get excited they occupy empty orbitals. Here already one orbital of D is occupied by the electron of P. So the s electron is also jumps to d orbital because d orbital has vacant orbitals here. Okay, now the number of electrons is 1, 2, 3, 4, 5, 6, which is equal to the number of bonds. Okay, now consider 6 electrons we require 1, 2, 3, 4, 5, 6. Okay, so in these 6 orbitals are involved in bonding. Well, which are those orbitals? Now this is hybridization. Okay, here one s orbital, 3 p orbital, 1, 2, 3, and 2 orbital, 2 d orbital. That is sp3d2. Next, hybrid orbitals. Here how many hybrid orbitals? 6 hybrid orbitals. 1, 2, 3, 4, 5, 6. These are the electrons of sulfur. This is sp3d2 hybrid orbitals. So the next one is hybridization of SF6 molecule. So here initially write the box diagram. Okay, next the electron of fluorine is paired up with this. This is sp3d2 hybridization. Okay, now it is structure. Now it is structure. Okay, so structure, if it is sp3d2 hybridization, the structure follows is which one? Octahedral. Okay, the structure is octahedral. I write here. Now sulfur is here. Hybrid orbitals of sulfur 1, 2, 3, 4, 5, 6. This is what? Hybrid orbitals of sulfur. Here electrons are there. Next, the fluorine atom is bonded to sulfur. Listen here, fluorine atomic number is 9. Configuration is 1s2, 2s2, 2p5. So the last electron is a p orbital. Means like this. Paired up in the so they get paired up. So simply if you want to write, this is, listen, one bond, this one is another bond, okay, so here this is the structure. Here in the right, structure is enough. This structure is enough to represent. Are you getting? So here this means the bond angle is, of course, bond angle is 90 degree. In between each atoms, the bond angle, in between each bonds, the bond angle is 90 degree. So here you write the points here, that is sp3 d2 hybridization. First point. Second, octahedral structure. Third, bond angle is 90 degree. These are the points. This is the hybridization of SF6 molecule. Understood? Listen. So students, a simple formula is there to calculate the valence hybridization of the molecule. Listen, to find hybridization type of hybridization. So listen, initially I write here, if two orbitals, so this is orbitals, this is hybridization. If two orbitals, sp hybridization, 3 sp2, 4 sp3, 5 sp3d, 6 sp3d. Remember, this is the simple one. How many number of orbitals? So type of hybridization is equal to valence electron minus number of plus number of monovalent electron, okay, minus cationic charge plus anionic charge. This one whole just take half into valence electron plus number of monovalent atom minus cationic charge plus anionic charge. Are you getting? So listen, with this formula I'll explain some hybridization, then you will get to know. So I take CH4. We need to find out the hybridization of CH4 molecule. So carbon. So formula I write half into valence electron of carbon is 6. Sorry, 4. Plus number of monovalent atom. This one is hydrogen is monovalent, oxygen is divalent, nitrogen is trivalent. You know that. Monovalent means single bond formation. Trivalent, two valency. Trivalent, three valency. Okay. So this is, of course, hydrogen is monovalent means 4. Here on the species there is no minus charge, there is no plus charge. So this is minus 0 plus 0. Okay, so that is 1 by 2 into 8, that is equal to 4. So students, if 4 orbitals are there, which hybridization it is? sp3. So this is sp3 hybrid orbitals. Another one is same CO2 molecule. Okay, so listen. Here, of course, in the last class we already discussed here which type of molecule these are, which type of hybridization they are having. So, half into the valence of carbon is 4 of course. Here, plus number of monovalent atoms. This oxygen is not monovalent, it is divalent. So, plus 0. There is no net charge, so minus 0 plus 0. So that is what? 1 by 2 into 4, that is 2. Okay? If 2 is there, 2 orbitals are there, the hybridization is sp. We just check. The hybridization of CO2 molecule is sp, CH3 molecule is sp3. So just now I told, what is that? SF6 molecule. Let's discuss here. SF6. Same SF6 I'm going to tell you. Okay? SF6 molecule. Here the hybridization. So that is half into valence electron of sulfur, that is belongs to oxygen family, means 6, plus monovalent electron is how much? 6. There is no charge. So that is 1 by 2 into 12, that is 6. So if number of atoms is equal to 6, here which hybridization? That is sp3 due to hybridization. Just now we discussed. Means this is the simple formula to calculate the hybridization of the molecule, which is very important in the NEET examination, not for board. In board you cannot calculate like this, okay? You need to write the box diagram, you need to take the electronic configuration, you need to excite the molecule. Later the bonds are forming, you need to show the sigma bond and also the pi bond. Understand? So this one is the technique to find out hybridization in NEET examination, because in NEET examination they won't check which way you are choosing to solve the problem. They simply tell whether the given option is what you think is right or not. Only that matters. So this is the easy thing. So students, keep on practice this, because you are more concentrating on the competitive examination. So board you may score very easily, but in board examination compulsory questions are also there. If you practice those, you may easily get passed. But in NEET examination, everything is depends on your ability. So this type of techniques used to helps you people to do the good performance. Okay. So this is all about hybridization. So in this hybridization, of course, some terms are there. Those are called as band parameters. So before explaining that, so I'll explain the limitations of hybridization. So what is that limitation? Listen. So the limitation is, here just now I told you. So while explaining the hybridization, we considered only sigma bond. We cannot consider pi bond. Means this hybridization explains, of course, the shape of the molecule, the bond angle, everything it explains, but it fails to explain the formation of the pi bond. It doesn't give an account for the pi bonds. It considers only sigma bonds. Okay, and main thing, another one, it concentrates only on the orbitals of the central metal atom. For example, we are taking CH4, the hybridization of this only explains. Means we are considering the number of electrons which are involved in only central atom. We are not concentrating on the bonded atoms. This is another one drawback. Means we are not giving any account for the bonded atoms. We are considering mainly the central metal atom. Understood? Okay. So these two are the main drawbacks of this hybridization. Okay. So the next main comes here is what? The bond parameters. Okay. So the bond parameter means in that bond length is there, bond order, bond energy, okay, and you may say bond enthalpy, and also resonating structures, polarity of bond, and dipole moment. Okay, so we will discuss band combination. So first one is bond length, bond order, bond enthalpy, bond enthalpy. Next, resonance structure. Okay. Next, polarity of bonds. Next, dipole moment. Okay, these are the band parameters: bond length, bond order, bond enthalpy, resonance structure, polarity of band, and dipole moment. So let's discuss one by one. So first one is what? Bond length. Okay, so we discuss one by one. That is bond length. What is bond length means? So of course, if it is a covalent bond, if it is ionic bond, metallic bond, we can what is it? Define them in a different manner. But it comes to what? Specifically bond length. No matter whether it is ionic, covalent, metallic, coordinate, anything. So okay. So listen, what is bond length means? Equivalent, equivalent distance equivalent distance between nuclei of two bonded atoms. Okay, the equivalent distance between nuclei of two bonded atoms. No matter whether it is covalent bond, ionic bond, and any other. That is called as a bond length. Okay, so students, of course, this bond length is measured by using spectroscopic techniques because if HCl is there, we cannot see HCl how they are bonded. If any CH4 molecule, you know CH4 methane is a gas. How can we see gas in our neighborhoods? Okay, we cannot see. So here, this bond length is measured by using spectroscopic techniques. Understand? And the next one is, of course, types of bonds are there. That is covalent, means by sharing of an electron bond takes place. Okay, so there the bond length is somewhat different. Ionic bond is there, the complete transfer of electron takes place. There the bond length is different. Okay, next metallic bond, they simply occupy. So there is simply a force of attraction between the nuclei. That bond length is different. Okay, but the main thing is the equivalent distance between the nuclei of two bonded atoms is called as bond length. So this bond length is measured in meter, specially picometer. Are you getting? It's not centimeter, it's not millimeter, anything. It's picometer. Pico means 10 to the power of minus 12 meter. Or angstrom also. But most of the thing is measured in picometer. Length means, of course, meter. It is picometer. Why it is the distance between those is very, very less. How much? 10 raised to minus 12 times. Okay? Next. So this bond length is affected by some factors. So let's discuss factors affecting bond length. So the first one is size of an atom. Okay, so students, if size of an atom is more than bond length is also bond length increases. So I'll take the example here, that is, so HI, HBr, HCl and HF. So listen, here of course variance shall I write 2s 2p, this is 3s 3p, 4s 4p, 5s 5p. What is this? The valence electronic configuration of this. Listen, this is fluorine, this is 1s, this is 2s. This is chlorine, 1s, 2s, 3s. This is bromine, 1s, 2s, 3s, 4s. And this is iodine, 1s, 2s, 3s, 4s, 5s. So students, we know here, this is fluorine, chlorine, bromine, iodine. The size goes on increases when the number of shells is added here. The 1, 2, 3, 4, 5 size is more compared to this, and this. You are observing, right? So here hydrogen is bonded here as you overlapping of computer. Here. So what is bond length? The equivalent distance between the nuclear. Nuclei of fluorine is here, nuclei of hydrogen is here. So nuclei of chlorine is here, nuclei of hydrogen is here. So nuclei of Br is here, hydrogen is here. Nuclei of iodine is here, hydrogen is here. Okay, so now as the size increases, we are going to see the bond length also increases. Less, more. This is in this order. Means if the size of an atom is more, then the bond length increases. So this is the correct order of the bond length. I hope you understood how. Okay, so with the equivalent distance if we measure, if the bond length is more, sorry, size of atom is more, of course the distance from the nuclei increases. Then obviously the bond length also increases. Understood? Next, another one is multiplicity of bonds. Means if number of bonds increases, then bond length decreases. Means for example, you assume single bond, double bond and triple bond. So if the number of bonds increases, means 1 to 2, 2 to 3, then the bond length decreases. Means this one is having least bond length compared to this. So students, if here only single bond is there, the single bond length for carbon atom, and take CC atom. Carbon single bond length is how much? 154. And next, carbon double bond length is 134. Okay, this is what picometer. And this is 120 picometer. Means here if we write, this is carbon, triple bond carbon is smaller in size. Carbon about carbon less than carbon center, greater than carbon center carbon. This is the pattern. Means if the number of bonds increases, the size of the bond length decreases, or the bond length decreases. If the bond length is more, number of bonds is less, like that. Understand? Bond order is more. This is what bond order. Multiplicity means number of bonds increases, the bond length decreases. Okay. Next, the third one is, of course, type of hybridization. Types of hybridization. Okay, so listen, if it is sp3 hybridization, it is 111 picometer. sp2 hybridization, then it is 110 picometer. Okay, sp hybridization means, of course, it is 108 picometer. So students, remember here I told you, if the bond order is more, then the bond length decreases. sp hybridization means that is triple bond. sp2 means double bond. sp3 means single bond. We know that. So that's why here triple bond is there, bond length is less. Here the single bond is there, bond length is more. Here double bond is there in between. First single and the triple bond is there. Means same hybridization whether or it is what is the number of bonds. Both, if the types of hybridization is sp, sp2, sp3 means if the s character is less, then the bond angle is more. So bond length is more. Are you getting? So this is all about what? Bond length. So bond length means what? It is the equivalent distance between nuclei of two bonded atoms. So it is measured in meters, especially picometer. So factors affecting the bond length is size of an atom, multiplicity of bond, types of hybridization. So in size of an atom, if the size of atom is more, then the bond length is more. Multiplicity of bond. If the number of bonds are more, then the bond length is less. Next, types of hybridization. If S character is more, bond length is also sorry. If S character is less, bond length is more. If S character is more, bond length is less. Okay? So this is all about bond. So next we will discuss bond order. Okay, so the next one is bond order. Okay, so what is this bond order? The number of bonds formed between the atoms. The number of bonds formed between the atoms is called as bond order. Means, for example, hydrogen molecule. So that is H single bond H. Bond order is 1. So oxygen molecule, that is O double bond O. Okay, here the bond order is 2. Nitrogen molecule, so N triple bond N. So bond order is 3. Are you getting? Bond order means what? It is the number of bonds formed between the atoms. I am not telling only about these monoatomic, maybe polyatomic also, like CO2, CH4, anything. Okay, so there the bond order is how much? 1. So if you listen, carbon, methane, if we take. Okay, so here the bond order of hydrogen is 1. Bond order of carbon is 4 because it is forming 4 bonds, it is forming only single bond. So bond order of hydrogen is 1, bond order of carbon is 4. Here also C double bond, C double bond. So bond order of oxygen is 2, so bond order of carbon is 4. Okay, so this is what? This is the number of atoms formed in between the atoms. That is called as bond. So students, here you take another one. After this third one you take bond angle 4, bond angle 3, this is 5, this is 6, that is called bond order. Okay, next. So students, if we compare the bond length and the bond order, so listen, bond order is inversely proportional to bond length. Bond order is inversely proportional to bond length. Means if the bond order decreases, bond length increases. If bond order increases, bond length decreases. Means listen, single, double, triple. Bond order is 1, 2, 3. Here the bond length is how much? 154, 134, 120. This is what? This is bond order, this is bonds, this is bond length. If the bond order is less, size is more, means length is more. If bond order is more, the length of a bond length is less. Are you getting? So this bond length and bond order are inversely proportional. Okay, so the next one is bond angle. So it is the angle between the orbitals having bond pair electrons in the molecule. It is the angle between the orbitals having bond pair electrons in the molecule, that is called as bond angle. So students, this bond angle is measured in degree. This bond angle is measured in degree. Okay. So listen, bond angle is representing by writing the orbitals using lines. Means, for example, so if H2O molecule is there, we are writing like this. Here the bond angle is 4.5 degree, like this. So these orbitals, orbitals are like this. But instead of this, they are represented like this for our convenience. Understand? Next, listen. So factors of means the bond angle depends on type of hybridization. How? Listen. If sp3 hybridization, bond angle is 109.5 degree. If sp2, that is 120 degree, and sp, it is 180 degrees. So students, if S character here is 50%, here it is 33.3, here it is 25. So if S character is more, then the bond angle is more. If S character is less, bond angle is also less. Means the type of so the bond angle is depends upon what is it? The type of hybridization. And at the same time, here I write, it is also depends on repulsion. It is also depends on repulsion. How? Because CH4 molecule bond angle is 109.5 degree. NH3 molecule bond angle is 107.5 degree. And H2O molecule is 104.5 degree. So all these three are what? sp3 hybridized. Even though bond angle is different. Why? Because they consist of 0 lone pair, this consists of 1 lone pair, this consists of 2 lone pair. Like this. Okay? Due to the repulsion of lone pair, and bond pair, they exhibit a different bond angles. Means the bond angle means what? It is the angle between the orbitals where the bonded electrons are present or bond pair electrons are present. And at the same time, it is measured in degree, representing by this. It depends on two factors. One is type of hybridization, another one is repulsion between the electron pairs. So this is all about bond angle. So in the next class, we will discuss with bond angle, resonance structure, polarity, and the dipole. Okay, thank you.